Today we will proceed over functional and non-functional requirements. Okay. Firstly, when you are going to find the functional and non-functional requirement, you must think upon what is the difference between functional and non-functional. If we consider functional, then we may say that the mandatory things that is required to run any system is called the functional requirement. Okay. The things that we can ignore comes under the non-functional requirement. That means without that things, our function or system can work. Okay. Let's consider first example of college management system. Here we will find the functional requirement. Now let's differentiate between non-functional requirement. If I say college management system is there, then can any college work without students? No, students are the mandatory thing. Then faculty. Without teachers, there is no one of students or any college. Then books. Without books, students can't study. Then is lab facility. To do any practical work, student requires some labs. Okay. Then seating facility. Chairs or tables are included in the seating facility. Then we consider the non-functional requirement. In the non-functional requirement, facility of elevator, security, then library, bus facility, dispensary. Like if we consider how will you find out the non-functional requirement, then you have to think upon if we are talking about college. Can a student study without lift? Yes, lift is not mandatory thing. It is the extra amenity. Can a student study without security? If security guard are not present in your college, can you study? Yes, you can study. If the library is not present in your college, then you can study. This is controversial that whether you can study or not. I will consider it in a non-functional requirement. I will justify it like library is extra facility of books that is provided to any student. Okay, that is not the mandatory thing that without the library student can't study. A bus facility, can a student study in college without bus facility? Yes. A dispensary is a medical facility that is provided to one student, so it is again a extra facility that is provided to a student. So by this way, we will differentiate the functional and non-functional requirement. You may extend your functional requirement, you may extend your non-functional requirement depending upon your thinking. That which thing you can add in functional and which thing you can add in non-functional requirement. Functional requirement should be directly related to your system, that it should be directly used by your system. And non-functional requirement is indirectly used by your system, that is extra facility by which your system can work. Now, if we consider over next management system as restaurant management system. Again, what is the purpose of restaurant? To provide food to the person or provide food to the audience. Then food is the main functional requirement here. Then if we consider the functional requirement of a restaurant, chef or cook, without them it is unable to prepare food. Then third facility is seating facility should be there. Then manager should be there. So if I consider the non-functional requirement, facility of elevator, lift is there, security is there, facility of air condition is there, then billing software is there. Here I will add cashier. Then menu is there. Okay. Let's discuss. There are some controversial points where you may get confused whether you add this point under the functional or non-functional. Okay. Okay. If I consider restaurant, then food is directly related to restaurant. What is the purpose to go restaurant? To have some meals. So food is the mandatory thing. Who will cook the food? Chef or cook will cook the food. So again, this is directly related to restaurant. Where will you sit to get your food? So a restaurant must have one seating facility. A manager should be there to maintain the decorum of the restaurant, to maintain the coordination between you and the order that you have given. The manager is required. Then is the cashier, where you will pay your bill. If you include the waiter here, waiter may come in functional requirement. Okay, it may also come in non-functional requirement. This is a controversial, that if any restaurant is providing self-service, then there is no need of waiters. If self-service facility is not available in any restaurant, then you may include waiter. So if this type of query may arise, that whether you add that particular thing in functional and non-functional requirement, then you may add in either side, in functional or non-functional requirement. Then we come with non-functional requirement, facility of elevator, security, AC. These are all the non-functional requirements. These are all the extra facilities. Now coming to the controversial thing, that whether they should be added in functional requirement and non-functional requirement. I said cashier should be there, and it will depend upon whether the cashier is going to get bill in the form of cash or by generating some bill, or will directly say to you, this is your total amount of food. Okay, so billing software is not a required thing. If you think widely, it is not a required thing. Then menu is extra facility that is provided to you, that by which you can give your order. Okay, or you may directly ask to the restaurant manager or waiter whether this thing is provided in your restaurant or not. Okay, so menu is in the non-functional requirement. The next thing we will consider here is the hospital management system. So first thing is, why any person visit to the hospital? To get treatment. Who will go there? Patients will go there. Okay. First is function requirement is patients, then is doctors, third comes the nurses, fourth comes the operation theater, then comes the medical store. Now, if we consider the non-functional requirement, here is the lift, security, canteen or any cafe, or extra staff. Okay. Then again, we will think upon why we have included these things in our functional requirement. Without patients, what is the fun of hospital? Hospital is meant only for patients. Then who will treat the patients? Doctors and nurses will treat the patient. Then if there is a requirement, operation theater is there, then medical store is there. These are all the mandatory things. You may add here seating. Seating include bedding and all the things. Okay. Non-functional requirement here is lift, security. These are all the extra facility. Is lift is required to cure any patient? No. Security is required to cure any patient? No. Canteen is required to cure any patient? No. Staff is required to cure any patient? No. So when you are going to relate the functional and non-functional requirement, you must think upon firstly that which things are directly related to any system that you will include in functional, and which is indirectly related to any system you will include in non-functional requirement. By the same way, you can get the functional and non-functional of any website or any software that is available to you. Now moving towards our next topic of how to design an as-is and to-be system. Okay, when you will be provided with as-is system, then how will you generate your to-be system?
Customer are happy again and your business grow even faster. To do that, you need to understand what your process. So we understand what is as this process is, what you're doing the things today, how to deliver the service, how you produce the goods. And understanding the as is process is the stepping stone for you to analyze and to improve your business process. So we call this is a to-be process. To-be process is an upgraded version of your existing process. So you can analyze what is changed, what need to enhance to offer better quality service to our customers. So let's see how Visual Paradigm to help you to develop assets and to-be business process. Here is a very simple online shopping business process. The customer will place the order by sending the purchase order to us, and then the sales representative will check the stock level. If there is a sufficient stock, we will pack the goods and ship the goods and the order complete and send the invoice to the customer. If the stock is not enough, then we will suggest the customer to change the quantity or to change other stuff. So we request to change PO and the process start again. So it is what we're doing today. So to improve this process, we need to understand how we do the work, and this process we're showing very clearly how we do the stuff. The next step is to create a to-be process. The first step is to create a model to accommodate the current as-is process. Then we can clearly separate the as-is and to-be process. You just right-click on the Model Explorer and go to the model, and you can new the as-is process model. And then you add the business process diagram to the as-is process by right-click and go to the sub-diagram item and add existing diagrams. I take the as-is diagram, as-is process, and now the as-is process is moved inside the as-is process model. Then the next step is we right-click on the empty area of the diagram and go to the utilities. And to create the to-be process, let's just create. And then now we create the to-be process. You see this is a to-be process. It's exactly same as the as-is process, because the as-is process is the stepping stone. It's just like copy and paste. So let's try to improve the process. Instead of doing everything from the sales representative, we can add another role. We just add a link and then name it warehouse. And we want to put some things pack the goods and ship the goods to warehouse to improve the efficiency of the workflow. So we just drag it to the warehouse and position it better in the center of the pool. And we also want to change in, because after check the sufficient stuff, it go to pack the goods is not enough. We need to have something to do before, so we insert the task between the pack the goods and check sufficient stock. We just click the connector and then split with a shape. We just split with a task called request pack goods, something like that, and then we can position it in the diagram. So now the process changed to representative check the stock and then we'll request the pack of the goods, and then the warehouse will start packing goods, ship the goods. So it's really improved the turnaround times of the whole process. So let's go back to see our as-is process. You see, this is the as-is process and this is the to-be process, and they act like just two copies. And what is the linkage between them? Say if you have a packed goods in the to-be process, you want to know where is this task in the as-is process. You can use the transitor. You see the transitor on the right bottom corner. Then you click, you see where it is come from. It is come from as-is process, packed goods. Then I just go back. Then it send me back to the as-is process to see who doing this task in the as-is process, in current business process. Okay, you can also go another way around. From the ship goods, you can also go to see who will doing this work in the to-be process, in the future enhance the process. So you can see the transit tool and the to-be process. You just click. We will send you to the to-be process and select the ship goods in the warehouse department. So you can see the linkage. And this is a micro analyze. How about we want to know what is the differences between as-is and to-be in the big pictures? You can use the visual div. You just go to the modeling and then go to the visual div. You can expand the visual div dialog box by clicking the expand button. Then it will maximize to the full screen. And then you can select the comparison strategy of the visual div. You have ID, name, and transitor. And basically, we compare the as-is and to-be process. We need to use the transitor. As I showed you before, we record the transit from and to. And then the left one, my preferences is left is the as-is process, and the right, you remember to check the use working project. The right is the to-be process. Then now you see both the diagrams are showing side by side. I'm just making more space. And you can select what is changed. Say the warehouse. You see in the to-be process, the warehouse is the new one. So you see the new bracket new. And the sales representative, you see the packed goods is modified. It is on the right hand side is under the warehouse. On the left hand side is under the sales representative. And actually you can see in more details in text. You see the parent changed it of the packed goods is from sales representative to the warehouse. So you got all the details. And the request packed goods is the new task we just created in the to-be process. So this you can compare automatically by using the visual paradigm rather than just use your eye to compare two diagrams and spend the whole afternoon to sort it out what is the differences. Thank you very much for watching.
Now we will proceed to the remaining topics of our unit 2. First is use case diagram. As in the function requirement, use case diagram and prototype is a mandatory thing that you have to study. Okay. In the use case diagram, The UML consists of structure diagram, behavior diagram, interaction diagram. Structure diagram involve class diagram, component diagram, composite structure diagram, package diagram, deployment diagram, object diagram. The behavior diagram include activity diagram, use case diagram, state machine diagram. The interaction diagram include the connectivity with the behavior diagram, that is sequence diagram, communication diagram, interaction overview diagram, timing diagram. Use case diagram comes under the behavior diagram. Now using use case diagram, a use case diagram is used to represent the dynamic behavior of a system. It encapsulates a system functionality by incorporating use cases, actors, and their relationships. It models the tasks, services, and functions required by a system or subsystem of an application. It depicts the high-level functionality of a system and also tells how the user handles the system. Basically, how your system will work. This is the purpose of the use case diagram, to tell what is the relationship among the use cases, among the various departments which is related in your system, and how they will interact with each other, how their dependency will be, how their relationship will be, that will be represented in the use case diagram. Use case diagram is used to visualize, specify, construct, and document the behavior of the system during requirement capture and analysis. The behavior of any system is analyzed in the requirement capturing and analysis phase. Provides a way for developer, domain experts, and end users to communicate. What is the importance of use case diagram? As mentioned before, use case diagram are used to gather a usage requirement of the system. We are saying that use case depends upon the requirement gathering and its analysis. Depending upon your requirement, you can use that data in different way. What are that different way? To identify functions and how roles interact with them. That is, what is the primary purpose of your use case diagram. For a high level view of the system, it is especially useful when presenting to manager and stakeholders. You can highlight the roles that interact with the system and the functionality provided by the system without going deep into inner working of the system. If the developer wants to convince the client or customer that how that system will superficially work, then he can refer to the use case diagram. You don't have to go with the inner working, the deep inner working of the particular project. You can superficially tell by representing its use case by some diagrams, that by this way the system will work. To identify internal and external factors, this might sound simple, but in large complex projects, a system can be identified as an external role in another use cases. Use case specification. Use case specification is synonymous to use case description and use case definition and can use interchangeably. Use case specification define information that pertains to particular use case, which is important in understanding the purpose behind the use case. That is, if any use case is going to be designed, what is the main purpose of designing or that particular use case? Use case specification is written for every use case. Whensoever the use case is going to be designed, it is important to write its specification. Specification includes flow of events. Let's find out what are these flow of events or pathways. Flow of events describes how and when the use case starts and ends. That means starting and ending of the use case. When the use case interacts with the actor and the information exchange between the actor and the use case. That is, it provides the interaction among the actor and the use cases. Flow of diagram, the flow of events is derived from what perspective, not how perspective. The main emphasis of this flow of events is to what perspective is there. Then how it will go on, it is not the mandatory thing that will be considered here. Specific information like interface details and technical specification should not be included in the use case description, because in use case description it is only specified that how the system will work, what's going on, but exactly the what software or what technical specification is required to build that system is not included in flow of events. Use case descriptions serve as a bridge between stakeholder of the system and a development team. Flow of events is like system analysts produce use cases and use case specification in consultation with end users. A use case diagram programmer look at use case specification to understand complete requirement, that is your software requirement specifications. These are the following type of flow of events. First is the basic flow, then comes the alternate flow, then comes the exception flow. Basic flow is also called happy path. Why it is called happy path? When you are in a perfect situation, you are not facing any type of mistake or error, then you are in a happy way, okay, in which nothing goes wrong. It is a most common pathway. It usually depicts a perfect situation in which nothing goes wrong. Alternate flow of events or alternate pathway is a pathway that is still considered a good pathway. It's not just the most heavily traveled one. Means you may face error, but you are easy to compensate about that errors. Okay, that is the alternate flow of events. When you are having option, if this is not going right, you may go by this way. Then comes the exception flow of events. It is called exception pathway, or it is also called unhappy pathway. Things does not go as you have planned. As exception is an error condition that is important enough to application to capture. When you are designing one system, but it is not according to your requirement, it is giving some errors, it is called the unhappy pathway. Let's take an example here. First, basic flow of events. When you are going to ATM and you have successfully withdraw your money, it is called the happy pathway. Alternate pathways, you get to the ATM but could not withdraw money due to insufficient amount or funds in your account. Then it is alternate flow of event. Okay, you're able to assess the service, but there is some drawback by which you are not able to use it fully. Okay, then comes the exception flow of events or exception pathway. You get to the ATM, but your valid PIN number is not accepted. Means you are not able to access the ATM machine. It is called the unhappy pathway. Then comes the use case diagram objects. Use case diagram is a description of set of interaction between user and a system. The components of use case diagrams are, there are 4 components of use case diagram: actor, use case, system boundary, and what is the relationship among them. First comes to the actor. An actor is someone or something that must interact with the system under development. Actor can be human or automated system. Actors are not part of the system. UML notation for actor is tick mark shown below. That is, there are few examples have been given to you as say actor is represented in the form of student, faculty, or employee. There are 2 types of actors. One is called the primary actor and other is called the secondary actor. Primary actor acts on the system. It initiates an interaction with the system. It uses the system to fulfill his or her goal, even something we don't have control over. Secondary actor, it is acting on, invoked, used by the system. It helps the system to fulfill its goal. It's something that system uses to get its job done. External hardware and other systems. External hardware is the hardware device. It's a part of an application. It uses the system to fulfill his or her goal. the other system involved, it is acted or invoked used by the system. It helps the system to fulfill its goal, the system with which system interact. If we consider our primary actor and secondary actor, the primary actor is related with the external hardware and the other system is related to your secondary actor. Now comes to use case. A use case is a pattern of behavior the system exhibits. The use case are sequence of action that a user takes on a system to get particular target. Use case is a dialogue between actor and system. The use case is represented by oval sign. Here one example is add a course. If this is an activity that one has to add a course, then it will be represented in a use case. Then comes the system boundary. It is represented by rectangle. It helps to identify what is external versus internal. That is, what is the responsibility of system has. All the use cases have been represented in system boundary. On the left side of system boundary, a actor is represented. In between the system boundary, the use cases are represented. The external environment is represented only by the actors. Then comes the relationships in use case diagrams. As we have studied so far, there are four components. First is the actor, which is having two types, primary and secondary. Then comes the use cases. Then comes the system boundary. And last comes the relationships. There are 5 types of relationships in use case diagram. Here, association between actor and the use case, dependency among use cases, extend relationship between two use cases, include relationship between two use cases, and generalization of a use case. Let's study one by one. Now move into the relationship. These are the representation by which you can show the relationships. The dashed arrow sign of include by writing include over it. A dashed arrow sign of extend by writing extend over it. A solid line with association. Dependency will be dashed arrow sign. Generalization with the solid arrow sign. How to create use case? Firstly, you have to identify actor, identify use cases, look for common functionality to use, include use of extend. First comes the association between actor and use case. This one is straightforward and present in every use case diagram. You have to use few things here. Actor must be associated with at least one use case. A actor can be associated with multiple use cases. It is not mandatory the actor should be included with one use case. It can be related to multiple use cases. A multiple actor can be associated with a single use case. As in the example, a customer is there, he has to open account, he has to deposit funds. If he has to open account, then he has to concern with the bank employee. This is the relationship among them. Then comes the generalization. Generalization of actor means that one actor can inherit the role of another actor. The descendant inherit all the use cases of the ancestor. Here, if we consider one example here, then NRFC customer, the customer who is NRI has to convert currency, but NRFC is also a customer, so it is related to the customer. Then all the processes are same. He has to open account, he has to deposit funds and connect with the bank employee. Then comes the extend relationship between two use cases. Many people confuse the extend relationship in use cases. As the name implies, it extends the base use case and add more functionality to it. Here, there are few things to consider when using the extend relationship. It means you are providing with one use case and other use case is having some dependency on your base use case, then you have to use the relationship extend among them. The extending use case is depending upon the base use case. In the below diagram, calculate bonus use case does not make sense without the deposit funds. So you want to calculate the bonus or you want to calculate the interest in your deposits funds. But let's you don't have any funds in your account, then how can you calculate the bonus and how can you calculate the interest? So what is the main thing should be there? You must have some funds in your account, you must have some deposit funds in your account, only then you can extend this relationship. The extended use case is usually optional, it can be triggered conditionally, it is not mandatory that you must have some extended relationship. It will depend upon the use cases whether you are going to extend it or not. If it is having some dependency on the base use case, then only you can go with the extend. Here in the diagram, you can see the extended use case is triggered only for the deposit over 10,000 and when the age is over 55. This is conditional extend. If you are having age of 55 and your deposit amount is over 10,000, then only you can calculate the bonus, otherwise you can't. Then only you can go with the extend relationship. Then comes the generalization of the use case. This is similar to the generalization of an actor. The behavior of the ancestor is inherited by the descendant. This is usually when there are common behavior between two use cases and also specialized behavior specific to each use case. For example, in the previous banking example, there may be use case called pay bills. Suppose there are pay bills option is there. Then bill can be paid by various methods. Bill can be paid by credit card, by bank balance, by internet banking, by Paytm, by Google Pay. The number of options is related to many use cases. This is called the generalization. That means it is having one ancestor, that is pay bill. A pay bill can be further differentiated into very descendants. It may vary. Then comes the include relationship. Include relationship between two use cases. Include relationship show the behavior of the included use case is part of including base use case. The main reason for this is to reuse the common action across multiple use cases. In some situation, this is done to simplify complex behavior. For few things to consider when you are going to include relationship. The base case use case is incomplete without the included use case. Let's consider one example here. Again, if we have to update balance, then you can update balance. If you are going to deposit funds and you have withdraw the funds, then you can include here update balance. You have used the use case update balance. But update balance can only be happen if you have deposited some funds or you have withdraw some money. Then definitely, if there are two different use cases have been applied there, then there is mandatory thing, your balance will be get updated. This is the include relationship. Here we inclusive is mandatory but extend is optional. Let's take one more example here. Here the user has to apply some code. He has to log in. Without login, he cannot apply any code. That is first thing, that is mandatory thing. Similarly, when you have to check your mailbox, your main thing is you have to give your username, password and login. This is in the include. But if I say you have to send mail to your friend, it is not a mandatory thing that you have to go for. It will depend upon you whether you are going to send mail or not. Then it comes the extent. Here view course particulars. Here comes the extent. Whether you want to go to look at the what are the various courses that are available, it will depend upon you. What are the various steps to create a use case? Firstly, you have to identify the actor. You have to identify use cases, identify include and extend use cases, identify generalization, identify relationship, and draw use cases by using system boundary.